Hello everyone, welcome to physics. Remember, we are still on electromagnetism, and this is lesson number 2. This is how we are moving in this new topic known as electromagnetism. In first lesson of electromagnetism, we were describing some electromagnetism concepts, which include field pattern due to current in a straight wire. We also managed to show you how to determine the direction of magnetic field and some rules to determine the direction of magnetic field. So in today's lesson, we are going to do magnetic field pattern in a solenoid. Magnetic field pattern in the solenoid. Now let me show you how magnetic field due to a current carrying solenoid are produced. Let me show you how magnetic fields due to a current carrying solenoid are produced. But first of all, let us define what a solenoid is. So a solenoid is a long cylindrical coil made of number of turns of closely packed wire. A solenoid is a long cylindrical coil made of number of turns of a closely packed wire. So this is an example of a solenoid. So you see we have a long cylindrical coil made up of number of turns of closely packed wire, and this solenoid is also connected to current. So you see some arrows showing you the direction of current. So let us go into details on how magnetic field due to current carrying solenoid are produced. Now let us go into details on how magnetic field pattern due to a current carrying solenoid are produced or are formed by doing this experiment. So first of all, a solenoid is mounted on the rectangular piece of cardboard, and iron fillings are sprinkled on the cardboard. So what you need to do is to mount your solenoid on a rectangular piece of cardboard. Then after, you sprinkle the iron fillings on that cardboard. Secondly, the switch is closed and observe and draw the field patterns shown by the iron filling. So the purpose of sprinkling the iron fillings on the cardboard is for you to identify the pattern which is formed due to magnetic field. So the purpose of sprinkling the iron fillings is to show you the pattern of magnetic field. Then you can also repeat the experiment by placing a number of magnetic plotting compasses instead of iron fillings, both inside and outside the solenoid. So as I've already said, that you sprinkle iron fillings for just to show you the pattern of magnetic field. So you sprinkle the iron fillings for you to observe the pattern due to magnetic field. Then here they have used a number of magnetic plotting compasses instead of iron fillings. So the purpose of doing that is for you to observe the direction. So they use the magnetic plotting compasses for direction, while iron fillings are used for you to observe the pattern. Now let us see how the experiment will look like. So as I've already said, that a solenoid is mounted on the cardboard, and thereafter you sprinkle the iron fillings. So the purpose of sprinkling the iron fillings is for you to observe the pattern or pattern formed due to magnetic field. So you can see on the figure A that you have the iron fillings are showing you the pattern of magnetic field. Then you use a magnetic plotting compasses for you to observe the direction of magnetic field. So you can see on the figure B, which has used magnetic plotting compasses. So you can see that the magnetic field now, they have direction. So you use magnetic plotting compasses for direction and iron fillings for pattern. Then it is observed that the iron fillings arrange themselves as shown in the figure A. So you see the pattern there, you see the pattern formed due to magnetic field. So it is observed that the iron fillings arranged themselves as shown in the figure A. So there is no direction there, and that the plotting compasses show the direction of magnetic field. So as I've already said, that the iron fillings for pattern and the magnetic plotting compasses for direction. So after doing your experiment, you observe that. Now the question can be magnetic field pattern due to current carrying solenoid. How magnetic field pattern due to a current carrying solenoid? Now the solenoid behaves like a magnet. So a solenoid behaves like a magnet. We have already explained more on how magnets behave. So the solenoid behaves like a magnet. So if a solenoid behaves like a magnet, it needs to have poles. So you see our solenoid having a north and the south poles. So after doing your experiment, you see that a solenoid is behaving like a magnet. In previous slide, we already discussed that solenoid behaves like a magnet. After solenoid being mounted on the cardboard, solenoid can behave like a magnet. So for it to be a magnet, it needs to have some poles. So here let us discuss how these poles are formed. So here is a clue. If the direction of the current through the end being viewed is clockwise, then that end is found to be south pole, as shown in the figure B. So let us look at the figure B. They are saying that if the direction of the current through the end being viewed is clockwise, so you can see our solenoid and check at the end of that solenoid. Is it viewed as clockwise or anti-clockwise? So you can see that it is viewed as clockwise. So then that end of that solenoid is found to be south pole. It's found to be south pole, as shown in the figure B. So the clue is the direction of the current through the end being viewed is clockwise, then the end is found to be south. So if you can view that end as being clockwise, you can say that end is what? South. Then given the other side is north. And if the direction is anti-clockwise, the end is found to be north. So let's suppose that current is reversed, and the current is coming from where it's labeled south and is going to the north. So you see that current is being reversed. So at the end there, it will be viewed as anti-clockwise. So once it is viewed as anti-clockwise, then that end is found to be north pole. Then if that end is north pole, then the other end is south pole. So there is a clue. You see that we have anti-clockwise and clockwise. So the clockwise direction at the end of that is the end of the solenoid being viewed as clockwise. So if it's being viewed as clockwise, then that end is south pole. Then you also see the anti-clockwise one. If you view that end as anti-clockwise, that solenoid end, it will have a north pole. So this is how you can test for polarity, or how you can test for your solenoid to know whether your end of the solenoid is south or north pole. So in previous slide we were discussing on magnetic field pattern due to current carrying solenoid. So now we have changed the chapter. We are saying a magnetic field pattern around a short circular current carrying coil. A short circular current carrying coil. Now we can also perform an experiment. So here you mount a short circular coil on the cardboard, and then you sprinkle iron fillings on it. And you can also use the plotting compasses to plot the field pattern due to the electric current flowing in the coil. So the procedure is almost the same, but here now you are using a short circular current carrying coil. So this is how it looks. So you have your short current carrying coil mounted on the cardboard, and thereafter you sprinkle iron fillings on it, and you can also use plotting compasses for direction. So after sprinkling the iron fillings, that's the pattern that short circular current carrying coil show. So here at the point A, now at the point A, you see that the current is coming out of the cardboard, and at the B, the current is going into the cardboard. So you can observe that circular coil. You see at point A, where A is, you see current coming out from the cardboard, and at B, the current is going into the cardboard. So note the difference there. Now, to determine the direction of the current, applying the right hand screw rule or right hand grip rule at points A and B, the direction of field can be determined. Now you can determine the direction by applying that right hand screw rule. So let us see how we can determine that how we can determine magnetic field in that short circular current carrying coil with A current coming out and B current going into cardboard. Let us now dig further by determining the direction of magnetic field around a short circular current carrying coil. So we discussed this in a previous slide, that at point A the current is coming out of the cardboard, and at B current is going into the cardboard. So this is being shown by the direction of the current. You see at A current coming out from the cardboard, and B the current going down into the cardboard. So by applying right hand screw rule or right hand grip rule, at points A and B, the direction of field, the direction of magnetic field can be determined. So let us see how we can determine the direction of magnetic field using right hand screw rule. So here is the diagram. So as we have already said that at point A and B, at A current is coming out from the cardboard, and B current is coming is going into the cardboard. So you can at B, we can start using the right hand screw rule at B, because right there the current is going downwards. So we can use right hand screw rule. So right there we already discussed the right hand screw rule, that when current is going downwards, when turning the screw clockwise, the clockwise direction determines the magnetic field. So you can see there our fields on the other diagram, that at the point B the magnetic fields deflect clockwise direction. So right there we have used right hand screw rule to determine the direction of magnetic field. So we have set it B just because the current is going downwards. A right-hand screw rule says when current is going downwards, you are turning the screw clockwise. The clockwise direction determine the direction of magnetic field. So let us go to A. So to A, you see that the current, instead of going downwards, the current is going upwards. So we reverse the right-hand screw rule. So instead of turning clockwise, we turn anti-clockwise. So anti-clockwise turning show the direction of magnetic field, and at the other diagram you see the magnetic field being deflected anti-clockwise direction. So we have used right hand screw rule to determine the direction of magnetic field. So here marks the end of today's lesson. So in the next lesson we are going to discuss some simple electromagnets. So don't miss the next lesson.